Welcome to BKW Physics. This is Mr. McConley, and we're going to look at a setup here where I have three spring scales, and it's a resultant vector sort of situation. So, if I have a mass and I hang it from this solitary spring scale, it reads 10 newtons. Now, if I hang it like this, and I still look at the same spring scale, it still reads 10 newtons, because nothing's really changed. But what we're more interested in is now looking at the other spring scales and see what's going on with them. So these spring scales up here are actually reading 6 and 4. So that kind of makes sense, because basically they're straight up and down. And so 6 and 4, you add them together, it gives you 10. That's what this one's reading. Seems to make pretty good sense. Now, as I push these out a little bit, the one on the bottom is still 10. The one here is now up to 6, and the one here is now up to 6. So now we have 6 and 6. We got basically that these are 12 if you just add them. Which, of course, is not the way you add vectors, because remember, vectors have to be tip to tail and direction matters and all that. But I'm just trying to give you the idea that this thing only weighs 10, however it's requiring 12 newtons to actually hold it up. And this keeps getting worse and worse. In fact, I crank this out this way some. My setup's a little awkward, but yeah, like that. Now we got quite a severe angle here. The one hanging from the middle is this one, still 10. This one now is up to almost 14, and so is this one almost at 14. So you got like 28 in order to support only 10. And it's confusing to some people. And I'll get back to why that's happening in just a minute. And we related it the other day to, like, if you hold yourself up on the edge of the desk and you weigh 200 pounds and each of your arms has to support about 100 pounds if your hands are close together. If you put your hands out like this and pick yourself up, it's a lot harder, and you can actually feel in your arms that you're doing a lot more work, so you must be supporting like 150 pounds on each arm. And if you can hold yourself up like the Iron Cross, I'm very proud of you, first of all, and each arm is probably quite a bit more than your whole weight of your body. So, one thing I want to point out before we move away from this, though, is that if I get it, yeah, I'm pretty close there, not quite. If I get it so this angle, and this angle are identical angles, I'm getting close, but I'm not there. That looks pretty good, doesn't it? This angle, and this angle are the same. This is a key setup right here. And when we're at this point, then this should read 10, this should read 10, and this should read 10, and they just about do. These are a hair off, to be honest with you. I don't want to lie to you. They're slightly off, but I think if I tweaked it, probably my angle's off a little bit. Each of these is going to read 10 when the angles are all 120 degrees each. Now, what I want to do here, I actually drew a picture of what's going on because it's really hard to say in words what's happening. Can you see that?
Yes.
Okay, good. Now, if the resultant is this middle one here, and we said that one was 10, in either case, I got two scenarios, the scenario on this side and the scenario on that side. So in this scenario right here, I have it where the two spring scales at the top are a pretty small angle like that. So, right now, both of these arrows are pointing down. So I have to move one of them, do like the tip to tail method, okay? And which one do I want to move here? Well, I think what I'm going to do is actually I'm going to kind of move both of them. So I'm going to take A and I'm going to move it over here. Now I've moved A right there. And I'm going to move B over here. Now, A to B, the resultant is there. You see that picture? Make sense to you? Do the same with this picture. Now the second picture is as if, I spread it way out like that. And again, I'm going to move both of them just because I'm trying to show you something here. So this is A, going this way, and then I'm going to move B down here. B is right there. So you can see that these two components gave you a resultant of 10. And you can see that these two components gave you a resultant of 10. But what do you notice about this scenario? When you get to this wide angle scenario, what happens to the length of these component vectors? They gotta get a lot bigger. See how large these got? So as the angle up here gets bigger, the components have to increase quite a bit in order to give you the same resultant. And this is kind of the proof of what happens when the angle starts getting large with your arms when you're trying to hold yourself up like this. Then the components that will give you the resultant become really large, and each arm is actually supporting more than your own body weight. So for today, physics.